All right, so now we're going to move on to the last section of this chapter, and that'll be section 7.6. This is going to be broken up into 3 videos, and the first video will just be talking about natural logarithms and also showing properties. The second video is going to be solving equations. And then the third video is going to be a real-world example. All right, so what our goals or objectives for all 3 of these videos is going to be to evaluate and simplify natural logarithmic expressions. And then we're going to solve equations using natural logarithms as well. So what is a natural logarithm? Well, natural logarithm function or natural logarithm is the inverse to our exponential equation where e is our base. So if we have an equation y is equal to e to the x power, if we want to take the inverse of this, we will take our natural logarithm, which we will denote or write out as ln of x. All right, so that is a way that they are their inverse operations, or I'm sorry, they're their inverse functions, and they're also the inverse operations that will allow for us to solve exponential equations that have a base e. All right, just to show a little bit more detail of natural logarithms, remember that natural logarithms and exponential equations with the base e, they are inverse functions. So here we have the 2 graphs graphed. The first one is our exponential with the base e. And then our second one here is our natural logarithm that's graphed. Now remember, since these 2 are inverses of each other, their characteristics or their properties or traits change, meaning the domain of our original exponential equation now became the range of our natural logarithm and vice versa. And also they will be reflected about that line y is equal to x if we were to graph that there. So they still hold all the same traits that an exponential does with logarithms that we've discussed in detail. But now natural logarithms go specifically with our exponential that has a base of e. All right, so now we're going to go through a couple of the properties with natural logarithms just to show that they have the exact same properties as the logarithms that we've learned before. So let's go through a couple examples. All right, so here it says, what is 2 times ln natural logarithm of 15 minus ln of 75 written as a single natural logarithm? So we will use the exact same properties that we had before. So this number that's being multiplied up front is actually represented by a power. It tells us it's a power. So we can rewrite this in as ln of 15 squared minus ln of 75. 15 squared is equal to 225, so we can rewrite this in as ln of 225 minus ln of 75. So now we know that this minus sign here tells us that we need to divide when we are combining these into one natural logarithm. So it becomes ln of 225 over 75. And then we can go ahead and this will give us ln of 3. Now, we could type this into a calculator and we could get a value for ln of 3, but that's not what they asked for. They said just write it as a single natural logarithm. So that would be your answer. That 2 times ln of 15 minus ln of 75 can simplify to just ln of 3. All right, now there's one more example that we're going to do and then we're done with this video. All right, so now let's do the last problem for this video. So it says, what is the expression written as a single natural logarithm? So same thing, we want to go ahead and we want to simplify this. So same thing we did first, these will need to be rewritten as a power. So then we will get ln of x cubed minus ln of 2x. Now what's important here is both of this needs to be squared, so that's why I'm writing it in parentheses, so that way I know that both the 2 and the x need to be squared. So this becomes ln of x cubed minus ln of 4x squared. We can then combine these, since our subtraction means division again, we can then combine these into one natural logarithm and say ln of x cubed over 4x squared. And then we can just simplify. And the x cubed and the x squared will simplify to ln of x over 4. All right, and once again, this one we can't do anything more because we don't know what the x is, so there really isn't any specific value that we can get for this one right now as is. So that would be your final answer. However, this one, as we're going to learn in the near future, this does represent a number, and we can type that into our calculator. All right, so that is it for this video, and we'll move on to the next one.